given the equation of the function, how many determine the values at which the function has the horizontal tangent?
Okay? So, it says, given an equation, how might you determine the values? What does it mean by the values? The x values, okay? So the x's at which the function has a what? Horizontal tangent line. So if it has a horizontal tangent line, what must be true?
There must be a relative minimum or maximum.
There could be a relative mix or a relative max or a relative min, but what else has to be true? It has to change from increasing to decreasing or decreasing to increasing. Okay? And
Constant?
the derivative is what? 0. Why is the derivative 0 if I have a horizontal tangent line? So if I have a horizontal tangent line,
There is no
isn't that like a constant function? Right? What would be the derivative of that constant function? 0, right? So anytime I have a horizontal tangent line, it means that the derivative has to equal to what? To 0, okay? So let's write that down. So horizontal tan lines have a slope of what? Of 0. So since they have a slope of 0, we can say that the derivative should equal to what? To 0. Okay? And we know that there may be a what? Relative max or min. We'd have to do some further exploration to determine which of the two it is, right? Okay. Let's look at these last two questions on the notes and then we'll be done and you can work on your assignment for the rest of the book. You ready, Ashley?
Yes.
Okay, here we go. Will you read that one for us, Ashley?
At what values of x will the function f of x plus x have a horizontal tangent?
Okay, so it says at what values of x will this function have a horizontal tangent? So what does that mean? How do I know where it has horizontal tangents? It has to have a slope of 0. What has to have a slope of 0? That tangent line, right? And what gives me the slope of a tangent line? The derivative. So I need to figure out where the derivative is equal to what? To 0, and then I'll be able to find out where I'm getting that horizontal tangent line. So we need to find the what of this function? Find its derivative, okay? So can we find it now really quickly?
Yes.
What is it?
3x squared plus 1.
3x squared plus 1, okay? And then I want to know where that derivative is equal to what?
0.
To 0, so I'm going to replace this with what?
0.
0. And now I'm going to solve for that x value that we set up here, right? We're looking for x's. We're going to find that x that when I plug in there makes it 0. Okay? Before we do that, I want you to think about the problem a little bit. What does the graph of this look like? It's a parabola, right? Okay? And it's opening what? Up? Okay. Alright. Let's keep going. Just think about that. So how would I solve this? Minus 1. So I have negative 1 equals 3x squared. And then? Divide by 3. So I have x squared equals negative 1/3. And then? I square root it. And what happens when I take the square root? Plus or minus square root of negative 1/3? Okay. Are those valid answers? No, why not? They are imaginary, right? How do I know they're imaginary answers? You cannot take the square root of a negative. So if I got imaginary answers, does that mean that there are any real ones? No, so what does that tell me?
That it is never crosses.
That there'll never be what kind of tangent line? A horizontal tangent line, right? Because the derivative will never equal what?
Zero.
To zero. It's not possible, right? It's possible at the imaginary places, right? But we'd have to travel to the fourth dimension. We don't want to go back there.
Okay.
Okay? Some of you have already traveled there.
I'm imaginary.
So this is an imaginary answer, right? Therefore, there is no real solution, right? So what we can say is that since the derivative never equal to zero, right? The original function f of x will never have a what? Horizontal tangent line. If I graph that original function, I'll never be able to draw a horizontal tangent line. If we looked at it, do you want to look at it?
Yeah.
So you can see why it doesn't have it? Alright, so let's look at it. X to the third, right? Plus x. There it is. Would you ever be able to draw a horizontal tangent line on this particular cubic function? The derivative was a parabola. Now, you're not dumb, okay? The derivative is a parabola, right? And it's a parabola that's opening up. So if you think about it, if you think about where this parabola is, then you would realize that this parabola will never cross what? Zero. So if you have that idea in your mind, because it's actually above the x-axis, so it'll never cross zero, so therefore it can never equal to what? Zero. So since the derivative can't equal to zero, the function won't have any horizontal asymptotes. So let me show you what the derivative looks like. That's a different function. That one was what?
X squared
3x squared plus 1. So do you see how the parabola is up there? So is that parabola ever going to cross the x-axis? So it'll never equal to 0. Understand? That's why I got you thinking about it before you continue. Okay, we could have stopped right here and just said it has no horizontal tangent lines because that parabola will never cross the x-axis. Right? Anyway, let's try another one. Look at the next one. At what values of theta at which the function blah has a horizontal tangent line on the interval 0 to 2 pi? So again, we're looking for where this function has a what? Horizontal tangent line. Therefore, we're trying to find where its what? Derivative is equal to 0. Okay. So in order to figure that out, we need to know the derivative. So let's find the derivative of this guy. What's f prime of theta? What's the derivative of theta? 0? Is theta a variable? 1, right? It's like x, right? Derivative of x is 1. Plus the derivative of sine? Cosine. Oh, that was easy. Okay. And now we need to replace this with what? 0, because we want to find out where this derivative is equal to 0. So can you tell me that already? Just by thinking of the graph of cosine? Do you know what the graph of cosine looks like? Like that?
Yeah, but I'm not exactly how I know it.
You don't know exactly how?
Like,
Just
what
like
I
that?
was in
And then what happened to that graph? It moved what? 1 up. So I got that curve and I moved it 1 up. Okay, so where does cosine equal 0 on the regular graph? In this interval.
at
Where are the x's equal to 0?
half pi and
Pi half? Yeah, it equals to it at pi half
and 1 at
and
the bottom.
3 pi over 2?
Yeah.
Okay.
Yeah.
Well, now it's not going to equal half. Now it's not going to equal 0. It's going to be what? 1, right? Anyways, I'm confusing you.
Yeah.
Let's just do it algebraically. So minus 1. So we're trying to find where cosine of theta equals negative 1. Where does cosine of theta equal negative 1? At pi, very good. So theta should be
I.
pi. Think about it, was it negative 1 right here?
5.
Yes. Easy? So then we can say what? F of theta, the original graph, will have a what? Horizontal tangent line at theta equals pi, because what? F prime of pi equals what? 0. At pi, the derivative is 0, and whenever the derivative is 0, Daniela, we have to have a horizontal line. Yes? Good? Got it? All right. Awesome. Okay, so with whatever time is left, work on the problems on your assignment. That way, if you get stuck, you can ask questions. Make sure you read carefully and try to understand what the question is asking before you answer it, okay? Yes, you may go to the restroom. Got it? All right.
Huh?
Ready, folks?
Yeah.
And then can I go to the restroom?